Take a look at a few more integral examples. So we'll take a look at the integral of secant. Now you could rewrite that as 1 over cosine. Then you might be trying u substitution. So if you're like, well, could I do this integral of 1 over cosine x dx? Let u be cosine, the derivative with du would then be negative sine x dx. But you don't have a sine x, so that's not a good choice. So you can't do that. This is one of the trickiest integrals that you will see. We're going to multiply this by a special 1 to allow this to work. So I'm going to multiply secant of x by secant of x plus tangent of x over secant of x plus tangent of x. This is just a special 1, right? Now, what I can do is I can distribute the secant over here. So this becomes secant squared x plus tangent of x secant of x divided by secant of x plus tangent of x dx. Now, this might not look like it's gotten any better, but it has. It has. I'm going to let u equal secant of x plus tangent of x. I'm going to let u be the denominator. Because the derivative of secant, if you remember the derivative of secant, that's going to be tangent times secant. So we have tan x secant x. And then think about the derivative of tangent, that's secant squared. So what you get is the denominator, when you take its derivative, is the numerator. So if you ever notice that, if you take the derivative of the denominator, you get the numerator, you should be thinking logs. So this becomes the integral of 1 over u du, which we know is natural log of the absolute value of u plus c, but then plugging this in, this is equal to natural log of the absolute value of tangent of x secant of x plus secant squared x plus c. So this is the integral of secant x is natural log of tangent x times secant x plus secant squared x. This is one of those facts that you should just store away in your memory. I don't expect you to rederive this. It's just something that if you're able to pull this out, that'll be great. Now let's take a look at what happens if we have bounds, just to practice a little bit of this. So natural log of x over x. Well, we could try doing u substitution on the denominator, but the issue is that we have natural log of x that doesn't really have any place to go. So this is where we have to get creative. There's going to be a lot of trial and error. Like I said a little while ago, you should practice doing u substitutions, try something and be okay with it not working, trying something different and being okay that it doesn't work, and keep trying and trying. Here, we're going to let u be equal to natural log of x. Why is that? Well, that's all because the derivative is going to be 1 over x dx. Now remember, the derivative of natural log of x is just 1 over x. It is not 1 over the absolute value of x. The absolute value only appears in the integral of going from 1 over x to natural log of the absolute value, not the other way. So I have 1 over x times dx, that's du. So this is now the integral. Remember, when we have our u substitution, we could do our bounds at the same time. So these are bounds for x. So when x equals 1, tells us that u, natural log of 1 is 0. And then x is equal to e, natural log of e is 1. So this is now the integral from 0 to 1 of u du. Now the integral of u is u squared over 2, evaluated from 0 to 1. So this just simply becomes 1/2. You would take a 1 squared minus 2, or sorry, 1 squared divided by 2, which is 1/2, minus 0 squared divided by 2, which is 0. So 1/2. Same thing over here. Now with this one, what I have going on is I again have a similar choice. I have 1 over x on the bottom and I have a natural log of x. So I'm going to let u equal natural log of x. then du is going to be 1 over x dx. Again, choosing my bounds, substituting those in, when x is equal to 2, I get u is equal to natural log of 2. And when x is equal to e squared, u is going to be natural log of e squared. But that is the same thing as 2. So I get the bounds that go from natural log of 2 to 2 of 1 over u du. Because natural log is on the bottom, so that's 1 over u. I integrate 1 over u du, and I get natural log of the absolute value. So I get natural log of the absolute value of u evaluated from natural log of 2 to 2. So I plug in natural log of the absolute value of 2 minus natural log of the absolute value of natural log of 2. Now, when you take absolute values of numbers, you know what those are. You know if numbers are larger than 0 or less than 0. So in this case, natural log of the absolute value of 2 is the same thing as natural log of 2. Same thing, natural log of 2 is also a number that's larger than 0. So the absolute value of it is just the same thing. So this is natural log of 2 minus natural log of 2. And that is the answer that we want. So remember, again, this is talking about areas of the curve under 1 over x times natural log of x between 2 to e squared. And there we go. U substitution with natural log.